With the latest update to Omniverse, a really cool and exciting extension was added to Isaac Sim that lets you control character animation behaviors through a list of commands. It also introduces a nav mesh for path planning the characters, although it is still in early beta. It seems actively developed, and I can see how this will be extremely useful for populating scenes in architecture, background characters and animations, and research for computer graphics in Omniverse. The tutorial only takes a few minutes to follow, so after that I wanted to explore controlling the characters by making them follow a moving goal. Let's take a look at some of the core functions driving the characters and how we can integrate them in our own scripts. Important to note, I made this the day after the extension was launched, so the code is likely to change in the future. Let's dive into the process. Now I'll walk through my exploration of the codebase and what led me to a relatively simple code structure to leverage the existing API. Here, we made a plane with a nav mesh, added a basic biped with an animation graph, and a single character for us to control, and a Python script that handles the character's behaviors. This script is found in the anim.people extension location, which we want to explore as well. Under the extension window, we can find the path and open in VS Code. Let's get the path to this script and assign it as the Python scripting attribute. Now let's open this same file path in VS Code. For convenience, I'm going to make the required text file in the same location as these commands. I make a new command.txt file and create a goto command. Like before, I'm going to copy the path under the window behavior control panel. I'm going to paste that path. After we save and reload our scene so that the behavior control panel is able to read the text file, we can press play and watch our character move to the position 220 in our scene. One of the key points I wanted to figure out was how to override the text file that is used in the tutorial and replace it with Python commands. For now, we add this text file so we can debug how it works. Let's open the VS Code debug extension to connect directly to our character behavior. Next, I'll open the omni.anim.people inside of VS Code. Let's add a few breakpoints to get a general idea of what's going on. Press play to start the debugging. At this point, you should see the VS Code debugger turn blue. We will press play so we can start stepping through the code. An important part of this script is inheriting the behavior script, which automatically runs on the primitives assigned, much like how Unity handles GameObject scripts on update. The init and play both call a new character, which resets most of the settings to a default one. We can also see from the docstring that init character is called at runtime, which creates an instance of a navigation manager. We can also see it is where the command variable gets set from reading a file. When we hit play, the onPlay breakpoint is hit. This renews a character. As we continue through, we will hit the onUpdate. If there is no character, we initialize it. Here, we can see where the read commands from file is actually called. Next, if the avoidance flag is true, it publishes positions. Importantly, the commands is checked, and if we have a valid command, it tries to execute. Now it checks if there is a current command, and if not, it gets the command. In get command, we can see how the goto command returns a class instance of goto. If we step in, we see this is a class in the commands folder. On initialization, a call to the navigation manager is made, sending the goto location to a generate goto path function. If we look at the next step, once we have a command, we call the execute command method. Since the current command here is the goto class, we can step in and see that execute calls update and update calls a walk command. Again, we can step in and see that the walk function has some returns if we reach a destination. Without getting too detailed, this is important because we want to make sure that this never happens and instead updates the path. For now, we'll remove the breakpoints and continue on. Now, if we break again, we'll see that there is no execute command. At this point, we have enough knowledge to start overriding some of these functions. We'll open up a blank extension template. First modification is going to be to the extension toml. Under dependencies, we need to add the navigation and people and viewport requirements. We will create a file to hold my custom behavior, which is currently independent of my actual extension. We should now import the people extension and the required goTo class. We now create a class which inherits the character behavior. Since we don't need any of this highlighting, I'll remove this so we don't have to import the SDF. Since our aim is to follow an xform prim, I'm going to create a function called assignedGoal that will get the prim under the character. We just need to make sure that we have a target goal prim wherever our scale root is. We need to make sure that the target prim is accessible. So when we initialize the character, we also want to call this assignedGoal. Since our main aim was to replace the text file that was required, we're going to write this function that overrides the previous one, and instead of reading from a file, simply returns our given command. Similarly, we're going to override the getCommand function and return our own goTo. The reason is we want to make our own goTo class, which we can use to add functions so that we can update our path. Now I'll make a custom goTo Python function. The only thing we need to import is the existing goTo class. We will do a basic initialization of this class, inheriting and calling super. The real difference of this class is going to be our function called updatePath. When we call updatePath on the goTo function, it's going to use the navigation manager and generate a new path given our command. Now we can replace this commands.goTo with our own custom goTo. Rather than importing the old goTo, we need to import our new custom goTo. But to make things easier, we can rename this back to goTo. Next, we're going to copy the onUpdate function from the original character behavior script. The only difference is, rather than executing the command initially, we want to check that we have a new goal position based on our target goal. I'm going to use the omni.usd utils to get the world transform matrix and extract the translation. To do that, we need to import omni.usd. After we have our goal position, we're going to define a new goal that includes the rotation value at the end. Finally, after we execute the command the first time, we're going to make sure that the current command is updated with our new goal. This current command is going to be our goTo command, which is why we needed to have our own class so that we can write this function updatePath. And updatePath will actually call generate goTo path in the navigation manager, continuously updating our path and never exiting. With our script ready, we're going to create a new xform, and we're going to label this target goal. At this point, we can go ahead and replace the existing script with our new custom behavior one. Now we can press play and see that the agent moves around following the existing target goal, which is located here. When we move it, the agent will continue to follow it, and even when they're on top, because we keep updating the position, we never end this command.